up on the board here I have a 30, 60, 90 right triangle with the exact measurements of the sides for a 30, 60, 90 right triangle that is for sure correct. Alright, that is the exact number. Anytime you see the word exact in math, that means that we're not getting approximate decimal values, we're getting square root expressions like this. If I were to apply the Pythagorean theorem, a squared plus b squared equals c squared, it's going to be 1 squared plus the square root of 3 squared is supposed to equal 2 squared, right? Leg, hypotenuse. 1 squared is 1, the square root of 3 squared is 3, 2 squared is 4, 1 plus 3 equals 4. It's true, right? And not just because that's true, but if we think about trigonometry, look at the 30-degree angle. What side's opposite? 1. Which one's the hypotenuse? 2. And we know that sine is opposite over hypotenuse, right? So sine of 30 degrees should equal 1/2, according to this picture. And if we were to use a calculator, which would have been nice to have been open before I started this video, and we'll wait patiently as it opens. Hang on a second. Just get some like background music to play while we're waiting for stuff like this to happen. All right, now I'm in radians. I just noticed this on my calculator. I don't know if you got the blue calculator. I don't know if it does that or not, but I want to be in degrees. So if I type sine of 30 in my calculator, it should be 1/2 according to this picture. And hey, it is. Ta-da. And also, let's look at this. The tangent of 30, this is the adjacent side, right? That should equal, tangent of 30 should equal 1 over the square root of 3. Obviously, my calculator is not going to display 1 over the square root of 3. But watch this. Tan 30 equals. All right, if I do 1 divided by the square root of 3, same number, right? So again, that's just verification of the fact that these numbers are accurate. It is always true. That's the ratio of the sides of a 30, 60, 90 right triangle. Now, if this is a 1, that's a 2, this is a square root of 3. The 30-degree side is always half as big as the hypotenuse, and the adjacent side is always the square root of 3 times the opposite side. That's just what they are. So if this is 10, that's 20, that's 10 times the square root of 3. If this is 5, that's 10, that's 5 times the square root of 3. If this is 40, this is 20, that's 20 times the square root of 3. So we have the ability to just walk around the triangle like that. We also have this as a triangle that's similar to any 30, 60, 90 right triangle. Remember similar triangles, right? If I have triangle A, which is right here, and triangle B is right there, okay? And we know that this angle and this angle and this angle equal this angle and this angle and this angle, right? Angle, 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 similarity. We know the side is proportional. So let's say this is 1 and 2 and the square root of 3. Let's say that's what we have, right? This is our 30-degree angle, that's our 60-degree angle. And let's say this is 60 degree up here and that's 30 degrees down here. And I know this, let's say, is 14. Square root of 3 over 14 equals 1 over x equals 2 over y. We have proportions we can set up, right? So if they give me a 30, 60, 90 right triangle, I immediately know it's similar to this 30, 60, 90 right triangle every time. So that's how we're going to do these problems. It says use similar triangles. That's how they want you to do this right now. Use similar triangles to find x and y. Usually a similar triangles problem has 2 triangles, right? Once you see a 60 degree and a right angle, which means the other side's 30, you want to draw the 30, 60, 90 right triangle that is similar to it in the same shape. In other words, put the 60 degree and the 30 and the 90 in the same locations. All right? So right now 30 is up top, 60 is bottom left, right's bottom right. So I'm going to draw it in that manner. 30 at the top, 60 bottom left, and the right angle in the bottom right corner. Put the correct numbers. Now sometimes, here's the thing. This is something you want to commit to memory. It's very easy. All right? 1 square root of 3, 2 is the order of size of those numbers. Are we all comfortable with that? That's the square root of 4, that's the square root of 1, so the square root of 3 is obviously between those two numbers, 1 and 2. If you didn't know that, square root of 3 is about 1.73. Ask your calculator, it'll tell you. 1.732, something, something, something. All right? If you remember the sides of these numbers, look at where they lie in relation to the angles. The smallest angle, smallest side. medium angle, medium side. Big angle, big side. Okay, so if you can remember these three numbers, 1, 2, square root of 3, just know that smallest, middle, big, put them in the same location as the smallest angle, middle angle, biggest angle. Okay, that's always true. All right? Any triangle, that's true. The smallest side is always opposite the smallest angle, biggest side is always opposite the biggest angle. So, I draw my right triangle, my similar triangle to that on my paper. I see the relationship of the sides, 5 and 2, and y and 1, and x and square root of 3 are the relating sides, right? I put my 3 fraction bars. I like to put the one where I know both numbers in the middle, right? So 5 and 2 are both opposite the right angles. Let's put 5 and 2 in the middle.
Is that a minus sign?
Something fraction bars. Fraction bar equals
okay.
fraction bar equals fraction bar.
I was confused. Pay attention.
All right. So 5 and 2, and I could have put 2 and 5. It doesn't matter where you put what. Just be consistent with what you choose. I put the big on top, the small on the bottom. That's what I did. Okay? Which means 5 came from the big triangle. That means x and y need to go on the top of 5. So x goes on one, y goes on the other. It doesn't matter which one you put them on. X relates to the square root of 3. Y relates to 1. Okay? So at this point, I've got my proportion set up. This proportion will find me the value of x. This proportion will find me the value of y. Let's start with y. Y over 1 is the same as y, right? So y equals 5 halves, done. If you didn't notice that, 2y equals 5, then you divide it by 2. Same thing, right? But if you get y over 1 equals, that's the same as y equals. So, you know, that one's already solved. Looking at the red one, cross multiply. 2x equals 5 times the square root of 3. Divided by 2. There you got x. When you're doing these similar triangles with a 30, 60, 90 right triangle, I'm looking for exact answers. I do not want to get decimal answers to these. I want radical answers. I want nice, pretty fractions. Do not give me decimals. Okay? If you end up with a square root of 3 in the denominator, multiply top and bottom by the square root of 3 to fix that issue. For example, if you do one of these problems, you get w is equal to 2 over the square root of 3. Multiply top and bottom by the square root of 3. Give me that answer instead. That's a better answer than that answer. All right? So, that is using similar triangles. So again, if you see use similar triangles, there's only one triangle there. It's going to be the magical 30, 60, 90 at this point. The next one we're going to visit down the road is going to be the 45, 45, 90. That's also got some special values to it. So we'll deal with that when we get to it. But just know that similar triangles, this should be on your paper. If you want to draw that on your paper too, that's fine. I can believe that you looked in your book and compared things to what you have on your paper. But actually visualize that, be able to see that, have it drawn on your paper, and it'll help you make sense of it better.